We've already had a little introduction to Chapter 3 in one of our last sessions when we started to talk about estimation. And we remember that one of the common ways to estimate is by rounding. So let's just do this opening activity to see what we remember from the last session. As I was looking over the homeworks, it seemed like it was clear to some, but still needed a little work for others. So let's give these a try. When I'm rounding to a certain place value, whether it's the tenths, the hundredths, the thousands, or is it to the nearest whole number, or tens or hundreds, we look for whatever's being asked, either in words or perhaps it's underlined like in these. So if I'm saying, let's look at that first one, and the place value that is underlined is the tenths. So I'm asking you to round to the nearest tenth. When I do that, I always look to the number to the right, and that tells me whether I'm going to round up or round down. 5 or greater tells me to round up, and if it's less than 5, 4 and under, it will round down. So I'm seeing that this is a 7, which is greater than, so I'm going to round up. Now I'm going to leave my answer 8 3/10. I was rounding to the nearest tenths. So when I say my answer, I want to round to the nearest tenth, 8 3/10. If I start adding zeros, that changes the name of the decimal. It doesn't change the value, it's equivalent, but they want us to end at that place value, so don't add more zeros. In my second one, the 3 is underlined, and that's in the hundredths place. Round to the nearest hundredth. So now I look to the right and I see a 2, which tells me to round down, means not raise that number up, so I'm going to have 12 43 hundredths. It's approximately. Here's my sign that says approximately equal to. It's about. In my next one, this is now round to the ones or the nearest whole number. So again, you look to the right and I see a 7, which is greater than 5. So I'm going to round up. So this is approximately equal to 326. No decimals there. On to my second row. Again, I see an underlined, or in this case underlined and red to really highlight it, that the tens place. So I'm looking now at the ones, and that's a 5. Remember, 5 or greater rounds up. This is approximately equal to 80. On to the next. Hundredths again. I look to the right, I see a 4, tells me to round down. I have 8 96 hundredths. Last one, I notice that the tens once again, so I look at the ones. That tells me to round up. It's approximately equal to 20. So looking at the place value, whether it's written in words, tens, hundreds, and so on, or whether it's underlined or somehow highlighted, that's the place we're rounding to. We then found out that we could estimate sums, and why we do that is sometimes to get a rough estimate, get about how much approximately is something, and is my answer reasonable. So we can use this as a form to checking our work if we're not sure our computation is in the right place. This also comes in handy if you have a problem to calculate and it's multiple choice. It might help you to eliminate answers that aren't reasonable. So on the left, we're going to calculate the actual sum, and then to the right, we're rounding to the nearest tens. Again, a reasonable place there, and we're going to see if our answers are close. So again, go ahead and add in the first column, get your answer, and just adding up your columns. And then I'm rounding 464 90 cents to, and again, I'm assuming this was money. I didn't put a dollar sign, but I'm going to assume this was money. Okay. I'm going to round it to 460. And then I'm going to take the second one and round to the nearest tens as well, get 120, and I see that I get 580, so it's approximately equal to 580, which is pretty reasonable. Let's do another calculation. Here's another addition problem. We're going to take this, and especially when we get like 3 different add-ins, it gives us a better idea if we're in the right area as far as our answer. Let's do the actual, and then we'll do an estimate to see if this is a reasonable answer that we get. Again, I'm rounding to the nearest tens, and I look to the right and I saw a 4, so that's 320. I'm rounding to the nearest tens and I see that I have a 1, so that gives me the 260. When I did the actual calculation, and then I looked at the estimate, well, definitely it's a reasonable answer. It's approximately equal to 580. We can do this with differences as well as sums. We could go ahead and calculate the actual. Then we can again round to the nearest tens and see if it comes out to something that's reasonable. Now, this is a good problem to use for an error analysis where someone gets something wrong and we could say, but wait, if we estimate, that answer can't possibly be right. And we'll take a look at this, and we definitely see that it's a reasonable estimate. So there's more than one way besides rounding to estimate, and another one is called clustering. When we're clustering, it's a way to estimate when there are several numbers that are very close in value to each other. So let's take a look at some of these. When I look at $4.50 plus $5.20 plus $5.55, they're all approximately equal to or close to $5. And I see that I have 1, 2, 3 of them, so this sum is approximately equal to $15. Let's see a second problem. I'm looking at $6.25, $6.45, $5.99, and $6.65. They're all approximately equal to $6. We're all near it, okay? Either a little above or a little below. And there are 1, 2, 3, 4 of them. So this is approximately equal to $24. This only works when we have numbers that cluster or are near the same value. Here's one more. I have 3 values here, and I'm looking to see where they all cluster around, and they all cluster, or they're all approximately equal to 50, give or take, and there are 3 of them. And in this case, this is approximately equal to 150. And you can go ahead and do the addition to see if it's reasonable, but I'm pretty sure that you'll find that it is. Now I'm going to stop there, but there is one more type, and that's called front-end estimate, and this is an even closer to the exact amount, and we'll look at this one in our next class.